All right.
Okay. Don't pick on the I know that.
Wait, is it on already?
Okay. So I asked you guys a question. What is the graph of z squared equals, or what is the graph z squared equals x squared plus y squared look like? So does anyone have any guesses? Sorry. Think it's a circle?
Yeah.
I think it's a circle. You think it's a circle?
Yeah, it resembles the equation of a circle.
Okay, so you think it's a sphere? So I have so you guys, we have sphere. Does anyone else have an idea?
What do you have in your hand?
Alejandro? A cone. Okay, so you think it's a cone? So, Christy? You think it's a semicircle? Okay, so let's think about that. So let's break this down. So we have z squared is equal to x squared plus y squared. What did we use yesterday in the lesson?
The distance formula.
The distance formula. So let's take a look at this. So if I wanted to find the distance from here, I would use x squared. So here's my x-axis, x squared plus y squared. So here's my y-axis is equal to c squared. Okay, so I have this shape right here. So I have this line. So pretend I have a right triangle. So being formed, here's a right angle, and here's the right triangle right here. So what is one way I can make this 3D? Okay, because right now it's only 2D. So what's one way I can make this three-dimensional? Okay. So what if I take this triangle, right? And what happens if I start rotating it? Oh. Okay. So I want you guys take 10 seconds. What do you think this is going to look like? Okay, so 10 seconds. Okay. Try not to yell out. Okay. All right. So let's see. Okay. So what do you guys think it's going to look like? I think I heard some people say it. Ben?
A cone.
A cone?
Yeah.
Okay. So we have a cone. So think about infinite many, so we have our right triangle, and think about infinitely many right triangles being placed there. So pretend here's one over here, and pretend I have infinitely many strings being attached to this. Okay, so it's going to look something like a cone. So let's try plugging it into my laptop. So I have this graph right here. So I have, if it could just come up. There we go. I have z squared is equal to x squared plus y squared. Okay, so you guys made a prediction. You guys thought it was going to look like a cone. Okay, so let's test that prediction. Okay. All right. Wait. Hold on. Wait. Let's put the brakes on. What am I seeing here? So I have
Double cone.
So I have two cones. What does that mean? Why do I have two cones?
We reflect.
Okay, hold on. Okay, so Julia, what did you say?
Because square can be positive or negative.
Huh. So she says that we have a positive or a negative. So let's go back to okay, instead of working with 3D, let's go back to what we know really well, like 2D graphs. So pretend I have y squared is equal to x. Okay, and I wanted to figure out, I wanted to solve for y. What would I do to get y?
Square root of both sides.
Okay, I would square root both sides. Okay, and I would have what's on the left side?
Y.
Just y. Okay, and then what I got on the right side?
Positive and negative square root.
Hey, yes. Okay, be careful. Plus or minus radical x. Okay, so let's try plugging in radical x. So if I plug this in here, or actually, I think it might be better if I use the calculator. So let me erase that. So let me graph this. You guys see that well? Yes. Okay. So I'll say, what if I plug in radical x? You graph that? Okay. I have half
A
it.
pergola.
So let's take a minute to graph the other side. radical x.
The other.
So I get this type of shape. So what is the shape?
Sideways.
That's an inverse
Sleeping
parabola.
parabola.
Okay, so a sleeping parabola. So it's basically a parabola except
Inverse.
on the side. So we're going to be working with that a little later on. So that's the same thing that's going on over here. So if I look back up here and wrong way, if I had, since we have z squared is equal to x squared plus y squared, okay, and I wanted to solve for z, so like you guys said, I would have to square root both sides. Z is equal to what? What should I
Plus
get?
or minus x plus y.
Plus or minus x squared plus y squared. So we have a plus or minus. So that is why, if I look over here, I have a positive, and we have a positive going up, and we have a negative going down. So let's think about this. So I have these two cones. What can we do with them? What do you guys want to do with them?
Cut them in half.
Want to cut them in half?
Correct.
I want ice cream.
Yeah. Oh, are we getting ice cream then?
Yeah, we should, in honor of the code.
In honor of the code?
Ice cream.
Okay, so
Birthday, we should get ice cream.
okay, let's maybe near the end of the not the period, but there end of the school year. So what else can we do with skulls? What else can we do? So
Find the surface area or?
okay, we find a surface area. So what else?
Find the volume.
You can find the volume. Rhea, you had something to say?
Then find the area.
Okay, so I'm going to give you guys a hint. If you guys read the title today.
Cut in half.
Well, so we can, what does the title say?
What happens when I slice the cone?
Okay. So, Stephanie, what is our title? What is the title of our lesson today? Okay, so how can we slice a cone? So if I have this, what can I slice it with? Does anyone have an idea?
A line.
Okay, katana. What do you think it is?
Like another line going.
You think it's going to be another line? So think about, or what do you think?
To isolate, because when you square root the positive or negative, you make it the regular form, but only leave it to positive and or negative.
Okay, all right, so,
You can restrict the one.
okay, so hold on, let's try to, okay, so think about a way I can just like, so I have this
So the
shape and I
x and
just
y
like,
plane.
say it one more time?
The x and y plane.
Okay, it doesn't have to be X and Y, but more importantly, it could be a,
I was thinking of parabola because that's what we're talking about.
okay, so we're gonna jump into that a little later.
Oh, the
But-
z.
Okay, so let's try not to yell. But David said something really important. What did you think it was?
Cut it with the plane.
Cut it with a plane. Okay. So, let's think about what's gonna happen. So, if I have this, okay, here's my cone, and here's our right side of the cone, and here's our upside down cone. And I decided, okay, here's my plane. I can, you see, okay, I'm gonna cut it, I can cut it like this, I can cut it like that, I can cut it like over here. And what do you think is gonna happen?
It's good.
Well, okay, so, what do you think, okay, so, if I cut it, and it's going through this plane.
Oh, it'll reflect the cone light.
Okay, so let's think about this. So suppose, okay, so if we look over here, I have y is equal to 2x plus 5, and then y is equal to x squared. What are some things we can do with those two
On the
graphs?
intersection. Point of intersection.
The point of intersection. So, if I have this cone and I have this plane, what do you think you want to find out?
Where they intersect and cut.
Yeah, so where they intersect or cut, right? So, right now, I want you guys to look at number 30. So, it's asking you guys, what is the graph of z? Is z equal 2 minus x look like? So, it's it's gonna look like, so think about z is equal to 2 minus x. What does that look like? So, take a minute and figure out what is this, when I graph it onto the plane, what is that gonna look like?
Is it 30 or 20?
That is 30. What's the value in there? Why? So, think about, okay, so when we said, when we're looking at 2D graphs, and it says x is equal to 3, what is that? What does that look like? There's no y, it's a line, right? So, if I have this minus x, what is that going to look like?
There's no y.
Instead of a line, it's going to look like a, we're working with, we're working in 3D.
No, we need y.
So what are we trying to cut the number? No, what's cutting it out? What does that exactly look like? What am I physically, well, there you go, it's like a plane, right? So it's now your job to figure out what that intersection looks like, the whole plane. So if I cut this cone and I just cut it with the plane, what's the intersection look like? Have an idea? Length? Okay, so I'm going to give you guys a hint. These graphing calculators are not 3D, okay? Unfortunately, you cannot just plug it in, look at it. I wish there was a calculator, but there isn't. Alright, so can I have everyone look back up here? Okay. So I asked you guys, what does it look like when I, try to intersect the cone and the plane, right? So instead of working with that, let's try going back to algebra and think about, okay, so what if I have a 2D graph? So I had y is equal to 2x plus 5, and then y is equal to x squared, okay? So how, okay, someone give me an idea of how do I find out the intersection?
You set them equal to.
Okay, I can set them equal to each other, okay? So if I set them equal to each other, I get x squared is equal to 2x plus 5, and then I'll just say, okay, x squared minus 2x plus 5 is equal to 0. And I would just have to use the Pythagorean theorem, or not Pythagorean, the Pythagorean formula to find my x, right? So if I have, so now I have these two equations, right? I have, instead of this, I'll just say z squared plus, z squared is equal to x squared plus y squared, and z is equal to 2 minus x. So right now I want you guys to figure out how I can use these two graphs, or two equations to figure out the intersection, okay? So trying to figure out, so over here we could, I substituted y for x squared, or I could have substituted x by radical y, plus or minus radical y. So right now I'm going to give you guys 3 or 4 minutes to figure out what I can use, how we can find the intersections of these two graphs, okay? So, like I said, the calculators are not 3D, okay? So you can try to graph them, but you're not going to get the full picture. So think about how you can do it outside.
Or you can solve it with three steps.
Right, instead of using this one, try plugging it in and plugging it into, Z squared plus, okay, plugging equals 2x, 2 minus x to the quantum equation. So instead of working with already if you have time at the end of the year, I'll show you some.
I wonder Yes.
Well, let's see, what do we, okay, so this is, so this looks the exact thing of, 2D, right? So how, okay, so now I want you guys to start to solve. What happens if I have a cone with z squared equals to x squared plus y, and I have to plug these in 2 minus x? How can I use those two equations to find the intersection?
So you lost that.
Okay, well, try, okay, so let me give you a hint. You want to get rid of these. Or, hold on, you guys said that's not going to hold on. Okay, Carl, what did you say?
Plus this and this.
Uh-huh, yes. And then what, are you going to get rid of the z? Okay, so see what happens in yeah, so, but I want you guys, probably, do that. Yes. Give you the homework.
Okay, so I got it between hold on. Either one you got it right. Either one got it.
Okay.
I'm thinking you have to make it equal to.
Oh, he does not do
Hold on.
I remember that show.
Okay, so what does that look like?
Hold on.
Okay, well, now it's confusing, right? Or, well, not for...
it's probably
very confusing. So how can I, but you just want to do that? Okay. No, this is fine. What did you say, what?
Okay, so you got the code here. Start at the origin.
This one came out?
There's parabolas of 4 rights on the y-axis.
You said something before that. What was like, a what?
It's called a parabola. But this isn't a parabola.
Okay.
But it's a sideways parabola.
Sideways parabola? Are you, so are you looking at that equation? Y is equal to no.
Why is
Okay, so if I set the graphic, what do you think the intersection is like? So you guys think about what happens to the intersection.
Hold on.
Okay, so what do you guys think of this? Well, you're missing something there.
What happens when you
Okay, so when you're taking the square root of 4x, you can't really
I was too busy watching that.
Yeah, or you go 4 minus 4 minus 4. Yeah, we have to sub it on.
Do I have to get on my people who don't like me? Hold on. Do I have to get on my people who don't like me? Duck done.
Yeah, I knew it was. That's why.
Do I have to get on my people who don't like dark and How do you not know what dark means? Exactly. I was like.
That's
All right. Yeah, but Cartoon Network now went like berserk.
Okay, so, can I have everyone look up here? So, okay, good, that's it. So I asked Alejandro, what he did.
Oh,
Okay,
I got that too.
okay. So, can I have everyone look up here?
Minus 7.
Okay. So, I have z is equal to 2 minus x, and then I have z squared is equal to x squared plus y. Okay. So, Alejandro, what was your first step? What did you decide to do?
My first step was to plug in 2 minus x into z squared equals x squared plus y squared.
Okay. So we decided to plug this into here, and then again x squared is equal, and then you multiply it out, and you ended up with y. Or let's start off. Let's end up over here. So let's work through it real quick. So I have x squared minus 4x plus 4 is equal to x squared plus y. Okay. I can cancel. Okay. So this is what I had, and we can cancel out the x squared, right?
Yes.
So you cancel these out, and get negative 4x plus 4 is equal to, I'm sorry, this is y squared plus y squared. Okay. Well, let's think about what this looks like. So let's solve for x. I think it might be easier if we solve for x. Then 4x is equal to y squared, and this is minus 4, and then x is equal to negative y squared over 4 plus 1. Okay, something like that. Now, let me ask you guys this. What is this? What do you think this is going to look like? What is this similar to? Well, let's see. What do you guys think? I think you guys hit it on the nail when I came over. What did you think this looks like? So think about it.
Both sides, like a sideways parabola. I was aiming towards that way.
Okay. Okay. So, David, can you say that one more time?
What's the sideways parabola?
You think it's a sideways parabola? So think about what the problem that I was showing you. X is equal to y squared. I had square root both sides, and I had y is equal to plus or minus radical x. So he thinks it's going to be a sideways parabola. So let's think about let's test that theory. So let's go back over here, and I'll say okay. Z is equal to 2 minus x. Graph that. And I look it over here. Okay. So our x-axis is going up and down. I'm not sure how to switch it. So our x-axis is going this way, and our y-axis is going this way. So what is the shape you see at the intersection? What is the intersection shape?
You can rotate it if you want.
Can I?
The bottom, just click and drag the mouse to rotate the graph.
Okay, let's see.
What's that number?
Okay. Oh. Okay. I'm just gonna leave it like this.
Okay.
So, if I'm looking at this, what does our shape look like?
It's like a sweeping parabola.
Okay. So
It is.
yes. Okay. So if I was able to switch my x and y axis and rotate it, it's going to be going this way, right? So it's going to look like a just do you want to say it one more time? A sleeping parabola. Now, if we go back to what we solved, we have x is equal to negative y squared over 4 plus 1. So that means, let's think about what this means. So the intersection of the cone and the plane.
They're opposite.
What do you mean by opposite? So, okay, so let's, so the intersection of the cone and the plane is gonna be this equation. Y is equal to negative y squared over 4 plus 1. So, in this case, so since we're working with 3D, what do you guys think our intersections can look like? So, well, let me ask, so when we're working with 2D graphs, we have y is equal to 2x plus 5 and y equals to x squared. What was our intersection? We had what for intersection? What did we have? What do you think it's gonna be?
Well, like, the intersections are like points, but like, if you put them together, they're usually like a line. The solution, like, looks like a line or something, but in this case, it would be like... No, the solutions were points, but in this case, it would be a line, my bad.
Okay, well, not...
Not like a line, but you know. It's
Yeah,
like,
okay, so I think you understand what you're trying to say.
They
So,
touch.
so over here, in the 2D, when we had intersections, we had individual points, right? But now, since we're working with 3D graphs, our intersection is now actually, what Maria said, it's going to be a line, or in this case, it's going to be a parabola, okay? So, right now, I want you guys to think about, okay, so I'm going to give you guys 3 or 4 minutes to think about what are some other shapes we can make by cutting a cone, okay, like 2 cones, with a plane, okay?
You can have like two on
Okay, so let's,
So long.
so I want you guys to take 4 or 5 minutes, I'm going to put the timer up. Take 4 or 5 minutes and figure out what are some other ways we can make, some other shapes we can make, okay? I'm going to give you guys 4 minutes.
For Apple.
Think about what are some other shapes that we can make. Okay, so when do you get circles, right? And then you have, like what type of, okay, so we could have a bird line, when would we get circles? Think about it like here. Let me take this ball.
It would be a circle.
If I have this, this is our plane. Okay, here, take this plane.
Oh, it's
inside it.
Whenever the values start to like actually come into play. And that's where you cut it, because like, if you don't have any Z values.
Ooh, a trapezoid.
You think it's a trapezoid? Trapezoid? So, you just make up your own shape.
Maybe.
So pretend we have a phone like this, right? We're just looking at an intersection. So when do we, if I cut this like this, what do you cut in that?
You can do it like all the way up.
Circle.
Because like that's all the points, because these are all the points that like, like the base shape is so like everything around it is gonna be like base shape.
So,
Like if this was a square and if you cut it, then the base shape would be like a square. I mean, if we were to do the base shape.
So think about, okay, so I'm gonna ask all three of you guys, so what happens if I take this plane and I slightly tilt it? Think about what happens if I do that. Never mind, why? Okay. So what happens, okay, so I'm gonna take this.
Is that actually like that?
They have a cone,
Yes.
and you look at the base of the cone, and it's like shape like
Okay.
that.
Yeah.
So that's just, like, all the way
Okay,
around.
let me see this.
It's kind of-
Let me ask you a question. Alright.
Even if you're doing
So,
the top part, like the base.
how can I make a circle out of
I
this?
don't know how to explain it.
Yeah, here. Like this, and cut it. Okay.
Along like here.
So what happens, okay, so what happens if I cut it like this?
It's like
We look at
like,
trapezoid.
Well, okay, so pretend this is a pulse. So this is imaginary, this is a circle, so there's infinitely many strands. Right? So what happens if I cut it like this?
It's still good.
You think it's still a circle? Yeah, so what, you think, you don't think so?
Oh, yeah.
Are you disagreeing? You guys-
No, yeah, that's what you said. Yeah.
Okay, so think about what happens if I take this cone and I tilt the plane slightly.
It's still be a circle, but like
Okay, so what does that look like?
slanted.
Okay, so,
You guys cut it from the middle.
so let's go back up here. Okay. So what were some ideas you guys got? What are some other shapes?
A traffic cone.
Traffic cone? What does that look like?
excuse me,
Right?
that's copyright.
Okay, let's see,
Ice cream cone.
Evan, give me an example of a shape you can get out of this.
A circle.
The cone, okay?
What's the original shape?
Okay, so you, okay, so I should have put that
Is
up.
there a paragraph?
So let me,
Sorry.
let me look at this. I should have put that up so you guys can visually see it. Okay. So,
What's the other one?
the other one?
Yeah, it'd be graphic, both of them.
Oh, you wanted to see both of them?
Yeah.
Okay, so let's,
Where can we find this, like, thing? Is there, like,
I remember a tutorial for a assistant.
okay, so we get something like this. Okay. So, Evan, what happens, okay, so if I have this cone, right? How can I cut it to make a circle?
Like that.
Okay.
Wait, make a circle?
Can you explain it in, words? So what do you mean?
Just go across.
Across, right?
Planting.
Okay, so do you guys agree with that? You guys have any, okay, say what time? Or? A circle? Okay, so what happened? Did you guys find another, other shape you can make?
I'm sure it's possible to make an ice cream cone. Physically.
Physically?
All you have to do,
Oh, wait, I have
Just
an
cut
idea.
off the
I have
first
an
layer
idea,
at the
I have an
origin.
idea. No, wait, stay.
then you have to get a series of
Alright.
They're like
Wait,
this.
I have an idea.
And do it
Alright,
especially
okay, hold on, wait, wait, wait.
almost in the smooth.
Okay, alright, so let's slow it down, okay?
I got it,
Okay, this is possible, I control, but let's see, what do you think?
And a lip.
You think it's an ellipse?
Yeah, because like, if you cut it slantways, like, okay, like slanted, then like,
What do you mean by slanted?
it's not, like, okay, like, however you turn it, like, if it's slightly even tilted, it's still gonna be an ellipse because the radius isn't the same from like all directions. So it's
Okay.
gonna be kind of different, so it's kind of gonna be an ellipse.
Okay, so you think it's, so let's think about that. So, Maria said it's gonna look like a lip, so instead of cutting it straight across, I'm gonna tilt it slightly, then cut it, okay?
Yeah, I got you.
So let's, right now, I want you guys, so, those were a lot of good ideas. So you guys got circles, we got ellipses. When we guys are graphing these, try to figure out other ways we can cut it. So right now, I want you guys to try number 32, okay? The equation of the plane is now z is equal to 2, okay? So it is parallel to the xy plane. So I want you guys to do number 32 and try to figure out what the intersection is going to look like. Okay? So I'm going to give you guys 5 minutes on that one.
On what?
I think Mr. Erickson's going to be here. I won't be here.
Oh, what about the...
I think she will be here. I'm not sure.
Thursday, like, you'll have to do.
Yeah, and
Oh,
like
that's
Friday's the last day for the grading.
Oh, yeah, I'll ask her.
Tomorrow we have a assembly.
You guys have an assembly tomorrow?
Yeah. Friday is optional.
Oh, it's optional, but I go.
Yeah. They talked about the only our meeting
Oh.
the only our meeting for
No, we go
No,
long.
I'm just going whenever one of them.
inform everyone of what happened.
This is like.
All right, so let's,
Teach us kind of the.
What is, are you gonna teach us?
Okay, so let's go back to,
And then.
the equation number 32. So I want you guys to figure out, what is that?
But it is, you know.
And then when you make a circle.
You think it's a circle? So what is the,
Square is 2, so it's only 4.
okay, so what does the circle look like? What's the,
Yeah, you're kind of.
oh, okay, so, give me the dimensions. What is, what's the radius?
4.
The radius is 4?
No, it's 2, isn't it?
Why is it 2?
No? Yeah, it's 2. It's
No, I think just.
R squared.
Okay.
No, but it's R squared, so 2 R times 2. So I'm at the square?
Okay,
No,
so,
but like, it's R squared.
yeah.
That's just simplified.
Oh, yeah.
Or like, if you do it for 5, so first you can do it for 5.
So what do you guys think? What do you guys get?
Not even half.
Okay, so I have the equation. So what can I, and, I have the equation.
It's easy with the 2 is just really.
Wait, so D equals.
No, so we're doing a different equation now.
Wait.
So just D equals 2. So think about D equals 2, D equals 2, and then X squared.
What do we do with?
Yeah, so it's gonna be a T shape, because the intersection, right? But what does that look like? Okay, so think about what happens, what's the intersection look like? So remember what we talked about, how we solved for, the equation? We had a,
I think it's a bit enough.
substitute.
Different.
Yeah, so I'll take one. So let's substitute it, 2 into X into 1, and this equation, which is a constant, what do you get? So think about what happens when we plug it in. Yeah, wait. Want me to move it?
Yeah, I just want to do it.
Move this like this.
You plug it in now, you got, I have no idea what it looks like.
Okay, well, okay, so.
Oh, I get it.
Okay,
Would it,
That'd be a circle with multiple legs.
okay, can you solve it, algebraically?
It's
And you have the equation. Okay, now, okay, what's that look like?
Oh, there's radius.
So, So, let's, keep that in mind. So, let's see. Would it? Well, okay. Well, think about, trying to solve the algebra. Okay, what's this graph? X squared. You. What's the right? So, the intersection of, again, X2,
What's the graph?
and this cone is like the radius of 2.
That's what, 10 hours.
It's hard to draw? There's gonna be like...
Wait, is it 20?
So let's go back over here. So I asked you guys, what happens if I graph this, or if I wanted to solve it algebraically, and you did, if you had no idea, I said, oh, see, equals 2, I don't know what that looks like. So I asked you guys to solve this algebraically.
For X or for Y?
Well,
For Z.
okay, so in this case, we're gonna have, okay, so remember, our intersections are gonna be 2D, graphs, right? So it's gonna have two variables. Okay, so let's think about what we can do. Dominic, what did you do?
Plugged it in.
Okay, so we had z equals 2, and then x squared plus y squared is equal to z. Okay. Okay, and then you just plugged in this back up here. Okay, we had x squared plus y squared is equal to 4. Now, what does this graph look like? Valerie, what does this graph look like?
She said a circle.
Okay, all right. All right, so she thinks it's a circle. So if I plot these two graphs, we're going to get a circle of radius, okay, radius of 2. All right, so let's go back over here.
Thank you. Thank you.
Start a new equation. Z is equal to 2. Plug it in.
Oh, wow.
And there you go, look. So this equation, the equation of the intersection is x squared plus y squared equals 4.
So how many, how many intersections do you have?
Different types of intersections? Well, like,
Infinite.
yeah, but the different types of like right. So, let's look at 1134. Okay, so 1134 asks, consider the graphs in the plane representative system on the below. Okay, so we have z squared is equal to x squared plus y squared, and then z is equal to 2 minus 0.5x. Okay, so think about, so right now we already established parabolas and we established circles. So what are some other things that you said we can make? An oval. So what's a better mathematical term for that?
An ellipse.
An ellipse, right? So let's.
Well, wouldn't you need the equation for that?
I don't need it.
Isn't it just a stretched out circle?
Well, let's look at it. So what does the graph tell us? It says z is equal to 2 minus 0.5x. So, all right. So
It's like, if that's a circle, it says like, you know where it's like x minus h squared part, for example, there's like a fraction, like,
Okay.
and then that part is like the numerator or something like that.
Okay. So let's try not to get off tangent. So let's try plugging in y. Z is equal to 2 minus 0.5x. Okay. Are you guys ready?
Ready.
All right. Here you go.
Whoa.
Okay. All right. So let's look at it from a top-down.
Whoa.
Circle.
Okay. So if I okay, so let's look at it at a vertical. So here's my cone, and look at the way it cuts it. It's not cutting it horizontally. It's slightly tilted, right? Now, if I look at that from a top view, I can see. Let's look at the top view. And so, if you look at that, I get an ellipse. Okay. So I heard some other stuff, some other things that you guys said. We can get a parabola, we can get a circle, we can get an ellipse. But there's one more thing that I'm. Hello.
Hi.
I'll just wait. I'm actually, going to give a presentation, or like, just let, people know about, an event, but I think it comes back, Erickson's class.
Oh, how long do you need?
I just wanted to pass out the flyer. I'll come back in like 2 minutes or.
Can you come back in 5? Is that
Okay,
okay?
sure.
All right. So.
Oh, you heard Happy Noise?
What did I say?
She was like,
I heard. All right.
It's an injury.
Okay. So, all right, so before we finish, okay, so let's talk about, I asked you guys, what are some other things we can make? So, if I have this code, right? So we talked about,
Wait, what if we do a triangle?
Is it still a trapezoid?
okay, hold on, wait. Okay, wait. Okay, I need you guys, okay. Remember what we learned about yesterday? The focus, I need you guys to focus now, okay? So I am the focus, and you guys are the points of a parabola, and I just do guys.
Are you the director?
Okay? So.
My ship's kind of stuck.
Bad joke. But, so, I have this cone, right? And I have a cone up here, and I have a cone down here. And I decided I'm gonna cut this down straight, not straight in the middle, but slightly to the side. What do you think I'm gonna get? So let's think about what happens if I cut it like this. What am I gonna get?
No, wait.
Half cone.
No,
What angle are you looking at?
Just cut straight like
Like
this.
an oval.
Yeah.
What angle
A
are you
deep
looking at?
oval.
Oh, like
It's a V from absolute value. Oh, wait,
Okay. Okay,
I
it's a parabola, right? Okay, so if we have this, okay, we're gonna cut it, and we're gonna get a parabola. And then what happens if I cut it like this? Yeah, because remember, I have two cones. What am I gonna get on the bottom?
You're gonna
Is
get
that what that?
Another parabola.
Another parabola.
No.
So, what do you guys call that if I have a parabola like this and another parabola going like this?
Wait, is that a
Positive constant.
Okay, so it's there's a term for it.
Corresponding
Okay. So it starts with an H, right? Okay. And then let me give you another. Wait. Let me give you it. Okay, don't say it out loud. What happens when a kid eats too much candy?
You get that.
Yes, hyper. Diabetes.
Okay.
Hyperbole. I always said hyperbole.
It becomes a hyperbola, right? So before she comes back in, so let's check this out. So I have x is equal to 4. Oh, sorry. Equals 4. And if I look at it, you guys see that? So I have my one parabola going like this, and then I have another parabola going opposite. Okay?
Cool.
So.
I'm saying the hyperbole, you just ignore me, and then you're
Oh, no.
giving us hints.
Okay, so
I was like.
I wanted to let other people to answer.
Like me.
That's why I wanted to try to take a break, or not take a break, but give more wait time. Okay, I'm not trying to ignore you. Okay, because I know you're very smart. Okay, so that's the problem. Hyperbola, sorry. So right now, I want you guys to work on 1136, okay? So I'm gonna